The use of a directional antenna is required by the ARISS team for making a school contact with the ISS. Over the years, I've deployed two different models: the M2 2MCP14 and the Cushcraft A148-20T. In 2014, I deployed both in order to compare them and determine if one was better than the other. This was my criteria for comparison. 1. The amount of forward gain. 2. The front-to-back ratio. 3. The ease of setup. And 4th, the ability to transport and store the antenna. In this video, I'll discuss the Cushcraft cross-element Yagi antenna. I found this antenna to have good forward gain and a good front-to-back ratio. It's easy to set up because one set of elements can be removed and then reattached using simple hand tools. And it's easy to transport and store due to the way the boom can be disassembled into 3 shorter lengths. However, there are 3 items I found that needed some improvement. They are: 1. The feed point components are a bit fragile and easy to knock out of adjustment during storage and multiple deployments. 2. There is no phasing or combining harness included with the antenna, since its primary market is for those hams wanting a sideband and FM beam on one boom. And 3. The boom-to-mast clamp is not robust enough. Let me discuss the feed point first. This is the original UHF connector assembly. If installed once and left in place, it's just fine. However, I found that between times of use, the tuning accuracy would be compromised because the feed point is difficult to keep secured when disassembled. I asked my machinist friend Bruce, N9BLU, to design and manufacture a suitable replacement. This new fixture is capable of securing either an N or a UHF chassis connector. I'll show the UHF connector in this video. The chassis connector has an 832 screw attached to mount the ready match rod. Bruce made this from a brass screw by first cutting off the slotted head. Then, using a collet chuck in his lathe, he faced off and turned down the screw until it fits snugly into the UHF connector. To secure the brass screw, I applied a bit of flux paste, then soldered it into place. I must admit here that in no way is this a weatherproof modification to the feed point. But since this antenna is deployed for just a few days at a time to support an ARISS contact, corrosion does not occur and it's not an issue. The newly designed UHF connector and threaded rod are assembled to the fixture. The boom mounting screw needs to be in place first since it can't be installed after the connector is attached. 440 screws are used to attach the connector to the fixture. Once everything is secure, it's temporarily mounted to the driven element tube. I install a lock washer and nut to the boom mounting screw to keep things in place for transport and reassembly. The ready match rod and tube assembly are installed to the connector using 832 hardware. The tuning strap completes the feed point assembly. The instructions provide measurements which I found to be quite accurate during antenna tuning. The elements and feed point are assembled to the boom sections using the supplied hardware. In order to feed both antenna sections and to gain the benefits of having both horizontal and vertical polarizations, I use a combining coax harness. Notice I feed both driven elements with the coax exiting the rear of the boom. This keeps the feed line out of the active portion of the antenna, providing a more consistent feed point impedance. I found that having an antenna with combined polarizations works quite well, and the signal does not tend to fade during a contact. The final enhancement made to the Cushcraft antenna is the boom-to-mast clamp. The original design is not suitable for multiple deployments. Each time the clamp is tightened to the mast, the clamp plate deforms a little. I've replaced this with one offered by DX Engineering. Their design includes saddles for the mast to nest into, keeping it secure. And on the boom side of the clamp, saddles are again used. Repeated assembly and disassembly can now be accomplished. The antenna is oriented so the directors point north. When assembling the antenna to the cross boom, the clamp is tightened up just enough to keep the antenna in place. The rotor elevation is at 0 degrees, so I check the boom for level before securing the clamp. The feed line is attached to the combiner and exits the end of the boom. The other end attaches to the antenna port on the preamp. I like to swing the antenna throughout the maximum azimuth and elevation positions to be sure there are no issues with the cables. After all the tests are completed, I return the azimuth to north and the elevation to 0. The installation of the preamp will be addressed in another video. Thanks for watching.